Hey y'all, we're starting two-sided limits today. No surprise here, but I've mislabeled your notes. So what I want you to do, it says left-hand limit and right-hand limit. This kind of we'll just leave it the way it is, but this is our right-hand limit and this is our left-hand limit. They're not like different notes. These are just examples down here. Okay, so we'll go ahead and get started. So if you remember last time, we talked about two-sided limits, and with two-sided limits, we saw it approaching from both the left and the right, and so it would squeeze like a pimple. And if our fingers would meet, then that was where the limit was approaching. But if we had it approaching from one way, one value, and from another way a different value, from the left and the right different values, then the limit did not exist. So in order to prove that, we're going to have to talk about one-sided limits. And really with one-sided limits, we'll have a little bit more of an opportunity to have those limits exist as well. There we go. So it says, so we have our left-hand limit and our right-hand limit. So left-hand limit is exactly how it sounds. It's the number that you're approaching from the left side of the graph, whatever it is. And you can barely see this, but this right here kind of is an A minus. A to the minus, kind of like the what's it called? We'll get back to that because I can't think of the name of it. But that is how we label that. And if we were looking at a graph, it's a normal axis, it goes 1, 2, 3, on up to positive infinity. And then this goes -1, -2, -3, -4, all the way up to negative infinity. And I'm going to go ahead and put positive infinity here just so we know. Okay, so the way to remember left hand is the minus is because we're coming from the negative. Sorry, I'm pointing, but it's flipped. So we're coming from the negative direction. So if we're coming in this way, get a different color marker. We're coming in from the, you can barely see that too. We're coming in from the negative direction. So that's where that minus sign comes from. The left, same thing, but we have a plus sign. Did I say left? I meant right. So if we're approaching from the right side, we have a plus, our function, and then whatever that limit is, we're approaching from the right. All right, let me get a different colored marker because that is invisible. Jeez. There we go. Okay, so we're going to run into some examples here. We're going to do some review while we're doing it. Okay, so again, remember we're doing examples, not left-hand, right-hand limits. So if you remember before, we have our two-sided limit. And so if I have, we'll just do this one here. So we have the limit, this marker's red, as x approaches 5 of f of x. So it doesn't have a plus sign, so we're talking about a two-sided limit. We'll do -5 because that's what it is. If we look at -5 from the right, and I'll draw that in. So from the right, we're approaching this value. From the left, we're approaching this value, and those are two different values. So because our hands don't meet, we do not have a limit. This does not exist. However, you'll notice that this one here is 5 plus. I'll kind of make that bigger. That's -5 from the right there, or from the left. No, from the right, because it's positive. So from the right, if we're following our graph, because this whole thing, the piecewise function, is our graph of f of x, from the right, we're approaching -3. From the left side, we're approaching positive 2. Okay, remember the limit isn't asking for the value, it's asking what it's approaching on the graph. Because if we were to look at the value of f of -5, that would be right here because it's a filled in circle. And here it's open, so it jumps up. So that value would be 2. All right, then we want to look at the limit as x approaches 1 from the right. So here is our value of 1 right here, our x value of 1, and our y value is going towards 2. It doesn't equal 2, it's just approaching 2. Okay, so we're going to use this logic here, our understanding of two-sided limits, to start proving some stuff about limits. So one-sided limits can do two things. They're kind of the same. One-sided limits can be used to show that a limit does exist, and that's if from the right and from the left and from the right, they equal the same thing. At the same time, if they equal something different, then the limit does not exist, which is why I put Mean Girls quote. It's the only time I get to talk about Mean Girls all year. Okay, so just to reiterate, if they approach the same value from the left and from the right, then we have that the limit exists. If they approach different values from the left and the right, then the limit does not exist. Okay, so we're still doing this graphically, but we'll jump into some examples here. Okay, we want to make sure we're paying attention to directions. All right, so it says graph the function and determine if the limit exists. Check from the left and from the right. Support your answer. All right, so it gives us the graph, but it doesn't graph it for us. So it gives us the function, I guess. And so we have -x² plus 3. I know what x squared looks like. There's no shifts or anything. So I'm going to go up 3. Graph it in green. Just be fun. Up 3. And then it's upside down because it's negative. And so I'm just going to follow that pattern there. And we have 3, 9. Oh, wait, no, wait. So that is the graph of -x² plus 3. It's asking what is a little bit crooked. There you go. -x² plus 3. So it's asking us what's the limit as x approaches 2 of g of x. However, in the directions it says using the left and the right. So we're using this one-sided limit. It would say, so graph and determine if the limit exists using one-sided limits. Okay, so I'm going to come down here and I'm going to look at what's the limit as x approaches 2 from the left of g of x, and what's the limit as x approaches 2 from the right of g of x. Okay, so here's 2, right here, this line. That yellow kind of came in handy. So from the left, coming in, it's approaching -1. And from the right, our positive numbers, it's also approaching -1. So because these two values are equal, this means that the limit as x approaches 2 of g of x is -1. All right. So for our next one here, we have a piecewise function, and we can tell because of these right here. So we have a piecewise function. So we're going to have to be careful graphing that. You should know how to do that. I would go ahead and pause here and try it. Make sure you're using pencil, that way you can erase. If not, follow along for the piecewise and then pause it once we get to the limit part. I'll remind you when we get there. Okay, so I have x is less than 3 and x is greater than or equal to 3. So I'm going to go ahead and put a line at 3 just so I remember where I'm going, and it's faint enough that we don't have to really worry about it too much. So I've got the graph of x squared minus 2 where it's less than 3. So I'm going to have an open circle here because I do not have an equal sign under there. So x squared minus 2, I go to my y-axis, go down 2, and then graph x squared, which is of 1 over 1, and then 2, 4, and then 3, 9, which is 7. And I have an open circle on that 3 line. And then it gets reflected over the axis of symmetry. So it's like right here, right here. So it looks like that. Okay? Then I have x plus 1, where x is greater than or equal to 3. So I'm going to have a closed dot. If I plug 3 in, I get 4. So you can either graph this line as usual, go up 1 over 1, but you wouldn't graph anything to the left of that line. Or you can plug that 3 in because it's included, and I get 4. So 3, 4, and then I just follow the slope of 1. Okay, we want to make sure we put those arrows on there because they continue on forever. So that was some good limit practice. I would go ahead and stop here, and just like the one above, find the limit from the left and the right. All right, I'm going to continue on. Hopefully you paused. All right, so we're looking at the limit of f of x as x approaches 3 from the left, and the limit of f of x as x approaches 3 from the right. And if the minus and pluses confuse you, like switching back and forth, go ahead and label all of them left and right and however. The best way to do it is just think of a coordinate axis though. Okay, so I'm looking at the limit as x approaches 3 from the left. So on the left side, you can see at 3 that limit is approaching, clear that up a little bit, the limit is approaching 7. On the right here, or I'm sorry, as we're approaching from the right, f of x is equal to 4. I don't know why it's getting so weird. We know very well that 7 does not equal 4. So the limit as x approaches 3 of f of x does not exist. All right, that's it. Hope you enjoyed the math here. I think those are really cool. I'll catch you next time.